Welcome friends. We had shared some video lectures and notes on cathode ray oscilloscopes, the YT plots, XY plots and Lissajous patterns. To understand a little more into the basics of the display which we observe on the screen of the oscilloscope or the display unit of the oscilloscope, and how we can obtain the ratio of different input signals in terms of frequencies, amplitude or the phase relationship, this session is being conducted. So you can email me the further queries to the email ID emmifaq@gmail.com. So let us start with the display pattern on the oscilloscope. We take a very simple example of YT plot for a sinusoidal signal on the Y plates, that is the vertical plates, and the sweep input. So the sweep input for synchronization should be such that it covers from left to right the complete length of the input signal to be analyzed. So sweep signal is a ramp signal, as you know. So this should be a linear, slowly increasing but fast decaying signal. So many times we call it a sawtooth waveform. So how we observe the pattern on the CRO screen? Let us see. You have a display unit of the CRO which is many times like this. So you have the Y plates and the X plates. So these are the Y plates, also called horizontal plate, and this is the pair of X plates, X plate, also called the vertical plates. These are the vertical plates. Now let us see when the waveform starts at the origin, how it is displayed. So when we apply the sweep input to the X plate and the unknown signal or signal to be analyzed on the Y plate, how it behaves. With time, you can say this is time, here also this is time. This is basically Y plate, so magnitude over here. So when I am applying the voltage across the X plate, which is increasing linearly with time, how we will observe that its scintillation will give the result on the screen like this. But at the same time, the unknown signal is also applied on the Y plate. So at each instant of the voltage applied, you can see how the response is coming on the screen. So say at the instant when time is t1, Y plate from the origin, it will increase to some point. Again at time t2, your x-axis display is this one. Against it you will see the Y display, this one. So if we meet these points, you will see that there is a pattern like this, which will go like this. So if the complete waveform is covered by the sawtooth waveform through synchronization, so you will see the complete waveform. So by adjusting the bias, you can adjust it in such a way that the center line is at the origin like this. So you can have the display at this point just like this. This should be the display. for yt. Now suppose I am giving two inputs, two unknowns at two different plates. Suppose for y plate I am giving a signal like this. Another input, the same signal, maybe you give the same signal with same amplitude and same frequency to the x plate. So you are giving it to the x plate and here to the y plate. Both are observed in time in reality, but in the CRO what you will observe? Let us see how it can be observed on the CRO. So you have the y plate, like this, and you have the x plate like this. These are the x plates. So both the signals are increasing simultaneously with the same magnitude at every instant of time. So we take the origin. Suppose I take the origin. I draw two lines at normal just to trace how the signal is changing. So suppose at some time t1, both the signals have this magnitude. So this is on the positive side of the y plate, maybe this point, and this is on the positive side of x plate, maybe this one. So this is the point. Then the peak for both the signal. So peak for both the signal. Here this is for first one, this is for the second one, the peak. So the middle point is this one. So I am seeing that straight line will be traced like this. After peak, both the signals will come down together, even reach origin at the same time. You can see they are reaching at the origin at the same time. So initially they are rising like this, then they are coming down like this. Now again they will return back and reach to the maximum. So here they will return back, again they will trace the path. So you can see this is a straight line at 45 degrees. For the case when both the signals are same across x plate and y plate. So for same signal or for signals with same amplitude, with same phase and same frequency, you are seeing the straight line at 45 degrees. Let us think a little differently. We see that two signals I am applying, same magnitude, same frequency, but 180 degree out of phase. These are 180 degree out of phase. Then what will happen? So these are the origins, these are the peaks, these are also the peaks, but in the reverse direction. So we can draw the pattern, the y plate, the x plate. So the axis I am drawing. So when I start from the origin, we see both the signals are at the origin initially. So at this point, as soon as the signal y increases, it reaches in the positive direction, but the other signal reaches in the negative direction with the same magnitude. So y it is reaching some point, say it reaches the peak, y reaches the peak, this point, and x reaches the negative peak. You see the negative peak means this point, you can see below. So the negative peak for x is this point. This point. So the combination is this one. So at the peak, first peak, y is positive peak, x is negative peak, so combination is this point. This is, I number it 1. So here I say this is T1. At T2 both are 0, so you are increasing from here to here, the peak, then coming back to the origin. Again y is at negative maximum but x is at positive maximum, so the combination is again the other end. So here also we can see that it will be traced to the peak and again it will go back to the origin. So again this is a straight line, but now what is the angle? This is 135 degree. So this is the scenario when both the signals of the same amplitude and frequency, but they are 180 degree out of phase. So the pattern you will watch on the CRO will be straight line with 135 degree with the x-axis. Let us go a little ahead, where I will discuss if both the signals are of same amplitude but the frequency changes, how it will impact. Let us draw it carefully. So I have the first signal for y. So let us take first cycle, then second cycle, like this. So here you have the peak T1, origin T2, negative peak T3, origin T4, positive peak T5, origin T6, negative peak T7, then it is coming to the same point, that is the initial point, it is T8. So here I mark it as T8, the same point. So the X input, the same thing is triggered but at different frequency. So here I get at T2 the first peak and at T4 the origin and T6 the second negative peak. So T6 and again T8, again T8 the origin. So I start like this from here, from T8 I am starting at T2 first peak, then the origin, then T6 the second peak, then coming to origin at T8. How the pattern will look like? So you draw the plates, Y plate draw first, then X plate you can draw. So we start tracing. So at the origin what we see, origin I am saying it is T8 at the origin. So at origin we adjust the origin. So you can understand that we can adjust the origin by using the sweep signal initially if both the signals are unknown to be compared. So with sweep signal you can find the origin and synchronize the wave. So once you have synchronized the waves, then you can give two different inputs to two different plates. Once you are giving the different inputs, how the pattern will be generated. So at the origin both the signals are 0, but as soon as the voltage across Y increases, the voltage across X increases, but that is increasing slower than the increase of the voltage across Y, that also up to time T1. So when the time T1 comes, then Y is at the peak, I mark it as peak, but X is not at the peak, so X is somewhere here. So both the combination should be something here. So this is the point of T1. you see when you are reaching the point T2, the signal across X is at its maximum. So X is maximum, but Y is not maximum, rather it is becoming 0. So X is maximum, Y is 0. So you can say that this is the point, right? So now gradually if you go further T2, the signal across X is decreasing, but at the point T3 where Y is at its negative peak, but X is decreasing, it is less than the peak. So Y is negative peak, but X is decreasing, it is less than the peak. So maybe some point here. So this is T1, this is T2, this is T3. So you say it 3. Then at T4 both the signals are reaching the origin like this. So this is the point 4. This is point 4, interestingly. So I combine these points. Let us see how it is looking like. See, I am giving the arrow here. Now go beyond T4, go to T5. Y is at its maximum positive, but X is little less than its maximum. So some point over here, this is 5.5. Next, when T6 has reached that point, Y is at 0, but X is at its maximum negative. So this point. Further we go, we find that at T7 Y is at its maximum negative, but X is little less than origin, so we can say that this point is traced. So this is 7, right? So the next point would be the point T8. So this is the point T8. This is the point T8. So we can say like this, right? So how we have traced, we see the number exactly. We are going like this from 5 through 6 through 7, going back to origin. So you see the arrow. We check the arrow. Here, interestingly, we see that the Y plate is touched twice. So when we have to check the frequency Fy by Fx, Y plate is touched twice, while X plate is touched once. Either side, either you can take the top or bottom, or right or left, or you take the total number of touches. Y plate is touched 1, 2, 3, 4 times, X plate is touched 2 times, so 4 by 2 is 1, whichever way you like. Now if we check the amplitude, how you find out? So the magnitude on the Y is measured by this, and magnitude on the X is measured by this. So if both the amplitudes are same, maybe you can take it here as A. Here also you take A. So amplitude AY by AX equals to A by A should be 1. But if it is different, then the ratio will be different. Depends upon the choice of the waveforms. So this is how we find the ratio of the waveforms. A very good example is when you have to find out that two signals are there. Maybe in the case of digital electronics, when you modulate or demodulate a signal, what happens that the carrier signal frequency, theoretically it should be at least 2 times the signal to be carried, that is the main signal. So carrier frequency should be at least 2 times greater than the signal to be measured or analyzed. Then these two voltages or signals can be compared by these two inputs of the CRO, and you can verify. Next example we can take when you have two sinusoidal inputs, but they are out of phase. I am taking the example when the first sinusoidal signal you can say this is to the Y plate. So this is here, you can say T1, T2, T3, T4, and again T1, again T1. This is to Y plate, to Y plate. The second signal, you see, this is 90 degree out of phase. So maybe we take it at some point when the first signal is the peak, the second signal starts at that point. We cannot say, okay, this is not exactly what I'm saying, that this is 90 degree, because if you, instead of time, if you multiply by frequency, it will become theta equals to omega t. Now I am taking t in this direction. If you take theta equal to omega t, so you can find it in form of angle. So at the peak you will see that this is 90 degree. So from the peak I am starting the input to the X plate. So it should go like this. It should go like this, just lagging behind by 90 degree. Now you see this is T1, so again this is T1, T2, T3, T4, then T1 again, so T1, T2, T4, T1 again. Here you can say that if the X and Y plates applied with the two different voltages, how it should come. One more, I take T2 for convenience. So we fix the origin first. So the axis for the origin, here is the origin. So in the beginning, Y is at the origin but X is at the negative maximum. Y is at the origin but X is at the negative maximum, this point. This is point 1. After some time T2, Y is at the positive maximum but X is at the origin. So this is the point 2. Then after some time T3, Y is at the origin but X is at the positive maximum. So this is point 3. Similarly we can trace out point 4. So I see a smooth form is produced and the arrow will give the direction of the development of the waveforms. So here you can see that something like a circle is produced. So if both the magnitudes are same, so we can say that this distance and this distance are same. So this is an ideal circle. So in case of both the signals are of same magnitude and same frequency, we will get an ideally circle kind of Lissajous figure, right? So here again, if the magnitudes are different, so this shape will be different. So it will not be circle, it will look like an ellipse. But at that time also we will see that the shape is symmetrical about the x-axis or y-axis. That is interesting. In this case ay equals to ax, so this is a circle. Let us see the situation when this is not exactly 90 degree. Suppose we change the phase difference between the two. Let us try it. I am plotting it. Let us plot it very carefully. This is the signal to Y plate. I am plotting T1. So this is the origin is T1, then T2, then T3, then T4, then T5, T6, T7, then T8, then T8, and eventually this should be T1. So below this again, input to the X plate, it should go X, So here also same thing should happen. This is T1, this is T2, this is T1, this is T2, this is T3, this is T4, this is T5, this is T6, this is T7, this is T8, and this is again T1. So here I am saying that we are taking T, we can take theta equals to omega T. So if I start at 45 degree, the second signal, first one, let us do it honestly. T4, T5, then T6, T7 again the negative peak, T7 negative peak, then T8, then T1. Second one will lag by 45 degree. So we see this is the pattern, negative peak, and it will reach the next one, that is T2 at the origin. So here how the pattern should look on the CRO. See, this is origin. You plot the origin, start, first signal is at the origin, but at the same time second signal is still negative, x-axis is negative. So first one is at the origin, but at that time x is negative. So we will find some point over here. Maybe you can say that this is the point where it is starting. Then at T3, so T2 is the origin for signal across x, but for y it is added positive like this. So T1 we shall say T1, T2, then T3 we see that y signal is maximum, but x1 is still not maximum, so this is the point 3. Then we see that T4, x is maximum, but y is less than maximum, so this is the point we can trace as 4. In the same way, if we proceed, we'll see that this is T4, then further y1 is decreasing fast, and then x1 is decreasing. So when x is at the origin, you see the point T6, at that time y is negative, but when y is negative, x is still positive. When y is at the origin, x is still positive. So we can trace the point like this. See, you can trace the point like this. Then when further to it, x is at the origin, but at the time y is negative. So this is 5, this is 6, and we are going further like this. So after some time, y is the negative maximum, but x is not the negative maximum, so we take this point. So this is point 7. So when x is negative maximum, y is little positive, more than negative maximum, so we take this point. This is 8. So how you are tracing the point, you see beautifully, you can trace this point like this. If we trace this properly, this point will be here, x. So you see the arrow here like this. The arrow will be like this. So we can see that the ellipse thus formed is symmetric about an axis which is 45 degree to the x-axis, and this angle 45 degrees same as the delay between the y plate applied signal and x plate applied signal, and the amplitudes of these two signals, this is AY is the amplitude, here for x input AX is the amplitude. So these two amplitudes can be checked from here, AY and AX from the origin, and if these two amplitudes are same, then AX equals to AY, and if they are different, then AX will be different from AY. So that will again determine another position of the axis of the ellipse. So this is all about the basic figures of the Lissajous patterns, and the combination of these different input signals can be obtained from the knowledge of the basic patterns which we have studied in today's session. So if you like this session, you press the like button and you can subscribe the channel. Thanks for your patient listening.